Welcome to episode 2 of Travelling Science. G'day legends, welcome back to Travelling Science, the show that's sharing science with the world. My name's Jesse Crow and I'm the Travelling Scientist, coming to you today from Melbourne in Australia. I'm a health science communicator, and on this podcast we interview researchers, doctors and experts, sharing their stories and ideas that can help us to live a smarter, happier and healthier life. Today's guest is neurodevelopmental toxicologist Elizabeth Plunk. She's currently working on her PhD in the University of Rochester Medical Center in the lab of Anya Majewska, where she's trying to figure out if certain human-made chemicals that are being used around the world could have a negative impact on brain development. In our conversation, she answers questions like, what the frick are PFAS and why are they everywhere? Are PFAS dangerous to our health? Also, how does one become a neurodevelopmental toxicologist? Why does science feel isolating sometimes? And are takeaway coffee cups safe? And we also discuss ideas like perfluorohexanoic acid, microwaving plastics, organophosphate-induced delayed neuropathy, the cerebellum, and morning rituals. But before we get into today's interview, I'd just like to quickly share a review of the podcast. This week's review says, "Dearest Jesse, you rock my science socks. I love your voice in my ear every Science Sunday, and I think we should be together." Do you know who said that? It was me, okay? I made it up. So please leave a review of the show to help more people find Travelling Science, and so I don't have to make any more reviews up. Alrighty, let's quit mucking around so we can get into this week's epic discussion with special guest, neurodevelopmental toxicologist, Elizabeth Plunk. Elizabeth Plunk, welcome to Travelling Science.
Thank you for having me.
No worries. So for the audience out there, would you be able to give just a little bit of background onto what you're studying right now?
Yeah, so I'm a toxicology grad student working in a neuroscience lab. So I am studying the effects of perfluorohexanoic acid, their effects after exposure during gestation and lactation on brain development.
Wow, that sounds very cool. Let's go back to perfluorohexanoic acid. What is that?
Perfluorohexanoic acid. Yeah, it's a beautiful name. So it is a chemical in the per and polyfluoroalkyl substances, or PFAS chemical class. But this chemical has been used in industrial and consumer processes for this one in particular since the 70s and 80s. It's used to waterproof your materials. It's used to stain-proof them. It's used to quench fires.
Perfluorohexanoic acid is a type of PFAS chemical that is used in a bunch of everyday products, but its bonds are so strong that it doesn't break down in the environment. And a report by the Environmental Protection Agency, or EPA, stated that it can accumulate in agricultural crops, and it has been detected in household dust, food products, and even in our drinking water.
That is correct. They're deemed forever chemicals because that carbon-fluorine bond it's unbreakable. It's one of the strongest bonds. There's been no evidence suggesting that they're able to break down in the environment or in our bodies, which you can imagine could be a problem if we've been making them since the 1940s, that everyone that we've ever made is still with us somewhere in the world.
We're eating them or are we drinking them? How does that work?
So yeah, we can be exposed to them through our drinking water, through soil. So think of your root vegetables. They've been growing in soils. Thinking about animals, if you're not vegetarian, what animals you're eating. Mm-hmm. Have they been swimming in the water their entire life, or are they eating the grass of soil that's been contaminated? So we as humans are exposed through the runoff of the chemicals and how they've contaminated water sources and soil sources, and then we get it through our food.
Wow, that's freaky. And so what you're studying, are you trying to figure out how it affects us?
So I'm so in the United States, we have the Environmental Protection Agency, or the EPA, And they have spent a lot of attention in the past decades looking at PFAS chemicals and do they need to be regulated? Does their use need to be regulated? And so the one in particular that I'm studying, there's been conversations about does it need to be regulated, but there's no research looking at how it affects the development of the brain. And so my goal is to provide research for these regulatory scientists to have the proper information they need to either create legislation or policies in the United States or even worldwide. Or if it doesn't harm brain development, we now know it doesn't harm brain development. And so people don't need to be concerned and no legislation needs to exist for it.
Right. So did you just say you know that it doesn't, or you're trying to find out if it affects the brain positively or negatively?
I'm trying to find out.
Right.
Check back later this year.
About PFAS, how did you choose that particular chemical that you're studying, and how many choices are there? How many chemicals are out there that people are using and throwing into the environment?
I don't even want to try to put a number on the amount of the options that I had. I was interested. I read a lot. I really took 6 months and I just read papers. What do we know? What do we not know? What's showing up in the epidemiology literature that we don't have research on to know? Like, is it okay that it's in the serum or is it not okay? And so being in the United States, PFAS right now are a really hot topic, especially these short chain PFAS that have replaced the PFAS that have been banned. And so like they just kept popping up in the literature searches and there's just been a lot of attention on them. And so because my goal is for my thesis to do something to change the world or to do something to make an impact, it was really timely to choose a PFAS. And then of all the PFAS, there's over 9,000 of them that have been discovered, but I think only 400 or 500 of them,
just a few hundred, whatever,
400 or 500 of them are in like rotation right now, like currently being used right now. And so, yeah, that's still a lot to choose from. And so I just, where the literature was pointing, just going back to what frustrates me the most is that there's not enough literature on these things. I chose the thing that had the least amount of literature on it. So that's how I got there.
Short chain PFAS, you said they replaced the other PFAS? These are just like smaller ones or?
Yeah, so I think a lot of people have heard most about PFOA and PFOS, so PFOS. And so as I was mentioning earlier, perfluorohexanoic acid means it only has 6 carbons in it, but perfluorooctanoic acid means that it has 8 carbons in it. And so when scientists, researchers, corporations were starting to acknowledge that PFOA that has 8 carbons in it could be harmful to human health, they just did the good old chop 2 carbons off. And so now it's perfluorohexanoic acid.
Better or worse, who knows?
We don't know yet.
I feel like a smaller one would even maybe just be more likely to cross through the blood-brain barrier and get into the brain.
And that's what's very interesting about this one is if you look at the chemical structure of it and the chemical structure of a fatty acid, which is necessary and critical for brain development, meaning it has its special doors to get through the blood-brain barrier during development. They look very similar. And it is hypothesized that this one, in fact, is getting into the brain through these natural doors that our brain has for fatty acids.
Oh my God.
Yeah.
They're coming for us.
Yeah.
If you had to have a wild guess, obviously we're just speculating here.
Mm-hmm.
Do you think that this chemical that you're looking at would have a negative impact? Or is that kind of, what's your prediction?
So I hesitate to have a prediction. So I'm going to just explain how toxicologists would think about this. And
yes,
so,
please.
Especially for the context, because I'm a neurotoxicologist and I'm interested in the brain, it's really important for you to ask yourself, can it even hurt the brain? So if I'm eating it, but then I'm excreting it out, can it hurt the brain? And so one of the questions that we started really early in my research is to ask, is it bioavailable in the brain? So does it even get to the brain? Because if it doesn't get to the brain, we don't need to really focus on it in the context of neurodevelopment. So there is literature in humans and in animals showing that this chemical does get to the brain, suggesting that it could harm the brain. But just because it's there doesn't mean that it's going to be harmful. And my favorite example that my toxicology professor in undergrad used to talk about is like mercury. We used to use those in thermometers all the time. And you having mercury in your thermometer in your house, you're not going to be exposed to mercury poisoning. Even though it's there, that doesn't mean you're going to experience mercury poisoning. So I'm taking that next step right now. So we know it's in the brain, but is it doing anything in the brain? And so that's what I'm working on. And I can make hypotheses, but I can't make predictions.
Fair enough. I totally understand. That's super interesting. I talked to a great science communicator, Australian science communicator called Dr. Carl once upon a time. And he has this radio show where you call up and ask any science question you want. And I could have asked him anything in the world. And I asked him, that little wax layer on the outside of apples, can you eat that? Yeah. Is that dangerous? And basically what he said was, it's completely inert. You eat it and you get a bit of wax when you eat an apple. And it just kind of goes through your system and doesn't really affect you.
Yeah.
So I guess it's possible that perfluorohexyl... Sorry. It's perfluorohexanoic acid. Come on, Jesse. It's possible that the chemical that you're working on is maybe just passing through the body or just sitting there in the body inert. Or maybe it's doing something, and that's essentially what you're trying to figure out. And whether it's having a negative impact on humans. So I guess your long-term goal, you said if you did this research and found some negative effects, for example, that would then go to create some kind of legislation to reduce the use of these chemicals, right?
Right. Yeah. So right now, this chemical in particular, there's no laws governing the use of it. So anyone can use it in any quantities, whenever they want, however they want.
So the government, industry, and big companies can use this chemical all day long because there's no legislation restricting its usage. Currently, there's not enough evidence suggesting that PFAS are actually harmful to us. We just know that they're constantly building up in the environment and in our bodies. But don't freak out. Elizabeth and her lab are doing the important research that needs to be done to get to the bottom of this.
And because these chemical, like the military uses them, tons of companies use them. And so my goal is just to provide research and to maybe hope for one day, maybe responsible use for these chemicals, because there is a use for them, but I think there is a difference between responsible use and maybe what's being done now.
Just creating buttloads of it and just putting it out on everything, just coating everything in this potentially harmful chemical.
Exactly, especially with like aqueous film forming foam or fire extinguishing foam. Like this is the main ingredient of it. And there's no responsible use legislation on these. I don't know. I think just using it responsibly, like when you're training with it, do you really need to use the real thing or can you use something else? So it's things like that I'm trying to maybe promote. That's what I hope my research can add to the conversation of the people who make these decisions.
Are there any huge challenges you're facing in your research at this stage? I know you're a PhD student, so that's obviously a challenge in itself. But
yeah, it is.
Yeah. Is there any specific challenges that you're seeing at this point in time?
Every day you could ask me this and I would give a different answer. But I think a really big challenge that I continuously run into is, so I am studying brain development, but I have a special interest in the cerebellum, which is a relatively understudied region of the brain. And so a lot of time, and then on top of that, I'm studying microglia, which are these resident immune cells of the brain. And there's not a ton of research to begin with on microglia in the developing cerebellum. And so now I'm throwing this possible insult on it. And so I've struggled going back to the literature and learning from past experiments on maybe what the most straightforward path is. Because I don't know, sometimes I feel like I'm kind of forging my own path, which maybe that's part of getting your PhD and learning. But some days it's so frustrating.
That sounds like really cool science. Like, I'm just going to figure this out. I have no idea. Because I suppose you need a reference cerebellum, I suppose, to compare the one you're adding the chemical to. But
yeah,
if you don't have that initial research, then it's a lot. It's a lot to handle by yourself.
Yeah, especially because like in my experiments, I'll have the controls so that I can compare to a normally developed or a healthily developed cerebellum. But it's just what experiments are the most appropriate to run. Yeah, what are the most useful reagents or antibodies and all of these things. And there's not a ton of literature to go on. So a funny thing is I'm doing a side project to answer these questions so that I know for my toxicology project what would be the best path forward.
Tricky. Very cool.
Yeah.
Tell me about yourself, Elizabeth. How did you get into neurobiology and toxicology?
Yeah, so I am originally from Tennessee. I went to university at the University of Tennessee at Chattanooga, and I had really no idea what I wanted to do. As a freshman, I applied to nursing school and I got in and I thought, oh, this is not what I want to do. And then I was just like, maybe I want to be a dentist. And so I started on like the pre-dental track. And then a year in, I was like, maybe I don't want to be a dentist, but I'm enjoying my science classes. And I thought that majoring in biology I would find out what I wanted to do. So I majored in biology and I started to think about being an occupational therapist, which still was on the healthcare realm. And with occupational therapy, I had to take a lot of psychology classes. So I was taking chemistry classes, biology classes, and psychology classes. And I didn't love the chemistry classes, but I liked the biology and the psychology classes. And I remember to abnormal psychology, I took it. And I was the only person not majoring in psychology in the class. And I remember when we would talk about all of these disorders, I would always ask the professor, but why? Like, you're saying we should use these medicines and these are the behaviors, but why? What causes this? And she would always just say to me, your major is showing. Like, that's the only thing she would say to me. She never had any answers, and it drove me nuts that we would be talking about this stuff, but not talking about what is causing, like, the underlying mechanism of some of these disorders.
Yeah, you were like, that's it. I'm going to figure this out myself. I'm going to get into it.
Yeah, I was getting really annoyed with the lack of understanding the mechanisms. And so I was going into my senior year of undergrad. I was getting into the really difficult science classes to finish it out. And I heard that the most difficult course on campus was toxicology. And I just had to take it. Like, is it really the most difficult course on campus? And I'll
show them.
Yeah, exactly. And so I remember I signed up for it and I was with people that I'd taken all these biology and chemistry classes with. And on the first day of the toxicology course, we went over different air pollutants. And I just remember thinking to myself, this is what I want to do. Toxicology is what I want to do. And I went to the professor's office hours that week. His name's Dr. Richards. I went to Dr. Richards' office hours and I told him, I want to be a toxicologist. How do I be a toxicologist? And he looked at me, like kind of looked up from his computer, and he said, let's get through the first exam. Let's not get ahead of ourselves. And then we can talk about this. And I said, okay. And I left and I did really, really well on the exam. And so immediately I came back and I said, okay, we got through the first exam. How do I do this? and he helped me on that path.
So you got interested in toxicology initially because of a challenge, I suppose, and then
Yes.
you found it super interesting and you wanted to learn more, but you were still interested in the psychology aspect.
Yes.
And I suppose, is that why you kind of combine the two, and maybe not so much just psychology, but actually looking at the brain to try and find the root causes of some of these mental health issues? Is that right?
Mental health issues, developmental disorders. Yeah, I was still really interested in all of that. But at my undergrad, there were no neuroscience courses to take. So, like, being a neuroscientist wasn't really an option. And so, whenever I applied and came to the University of Rochester, I was able to do lab rotations. And so in those lab rotations, I only rotated in neuroscience labs or neurotoxicology labs. And it really just cemented that that was the system I wanted to study. And then neurodevelopment is what I'm really passionate about.
Let me change topic a little bit. What do you do when you're not doing science? What do you do outside of the lab for fun?
Yes, I try to not think about lab when I'm outside of lab. I have a really great support system here that is made up of fellow grad students and other programs, also a few medical students. And so in the summers, we go outside, we play outside, riding bikes on the Erie Canal or just going on walks or runs, just something outside to get some sun and some fresh air. And then in the winter, because it snows quite a bit here, cross-country skiing. This year, I recently got into downhill skiing. And so really just physical activity.
Yes, very cool. I've been snowboarding for the last few years, which has definitely been taking time out of the lab, but it's very fun.
Yeah, you have to take time out of the lab.
Definitely. It's important for mental health and your neurodevelopment, I'm sure.
Yeah, exactly.
Are there any books you would recommend about this subject, like a book that someone might read to learn more about neurodevelopmental biology or toxicology?
Well, toxicology, I think Silent Spring by Rachel Carson is a real historical kind of book on toxicology and how people can advocate for change when it comes to chemical use.
Silent Spring is a book about how humans keep ruining the earth with harmful chemicals. It was written by Rachel Carson over 60 years ago in 1962, but it holds up. Apparently. I haven't read it yet, but it's been recommended to me by 3 different people on 3 separate occasions in the last month alone. So last night I bought it on my Kindle. It was $17.50. If you don't believe me, go and check it out. And while you're there, get yourself a copy. Incidentally, Silent Spring was named one of the top 25 greatest science books of all time, according to Discover magazine.
There's Dark Waters. It's a movie. I don't know if there's a book associated with it, but it's a movie that came out a few years ago talking about DuPont in West Virginia. Fact check me on that.
Fact checked, and she was so correct. Dark Waters is set in a town called Parkersburg in West Virginia, where animals start dropping dead randomly. And look, probably that's because of the huge chemicals factory that just moved into town. But hey, who knows? And this movie has the guy that played the Hulk, Mark Ruffalo, as well as Anne Hathaway. I just watched it on Elizabeth's recommendation. Great movie, check it out.
But it's a true story about people who were working at a factory and who were exposed to these chemicals, and the company was just hiding that these chemicals were harmful. And it's a really eye-opening, well-done movie, so I would recommend watching it.
Do you have any daily rituals you do as a student and as a scientist? Anything that any non-negotiables, something you need to do every day that you just feel helps you through?
Drink coffee.
Caffeine.
Wake up and have my cup of coffee. That is very much a ritual. Wake up. I like to have a quiet morning, but I don't like to rush into lab, so I'd rather wake up at 6 and get in around 7:30. The caffeine helps. A quiet morning helps. I listen to podcasts a lot because a lot of times you're alone. You have all your lab mates around you, but all of you are working on your own thing. So I always have my earbuds with me.
Definitely an early morning, not early morning. I'm definitely need some space in the morning give me a coffee, give me 20 minutes, and then we can talk science.
Yeah, and I always, whenever I come home, I try to immediately change clothes, get into like activewear, just cozy clothes, get out of the work clothes, laptops up. I'm not at work anymore, so my brain can't be at work anymore.
I love how you said activewear and comfy clothes at the same time. Like, I'm going to get into this exercise gear and then sit on the couch.
Yeah. And some days I do just sit on the couch, but some days I'm just that much closer to going on a run because I already have my running clothes on.
That's a super important ritual. I think getting dressed for something, even if it's not going to happen, like putting your running shoes by the bed is a really good way to wake up and be like, I should probably go for a run. Cool. I like that. So coffee in the morning, getting into your running gear, and listening to a good podcast to pass the time, because we learn so much. And that's why I created this podcast, so I can start sharing awesome stories like yours, and hopefully someone will listen.
My mom will listen.
Oh, hi, Elizabeth's mom. How you doing? What's her name?
Laura. I felt bad talking about all the psychology that I wasn't giving her a shout out, because she's an applied behavioral analyst. And so she was always coming home talking about people that she works with who have neurodevelopmental disorders or anything of the sort. And so I know she also introduced me. So my mom, I'm sure, played a role.
So thank you, Laura, for listening in and for raising an absolute gem of a daughter and a great scientist. I've got a couple of listener questions here, if you've got a minute.
Yes, of course.
But before that, every week here on Travelling Science, we donate to a charity of the guest's choosing. And this week, Elizabeth has chosen to donate to the Silent Spring Institute, which funds research into how we can protect people from cancer-causing chemicals and create a healthier environment for generations to come. So a donation has been made to the Silent Spring Institute. And if you'd like to support this show and contribute to our weekly donations, funding science and making the world a better place, you can find the Travelling Scientist on Patreon, and the link is in the show notes just below. Crashy Apples wants to know, are takeaway coffee cups bad? Surely there's some chemical, non-stick, heat-proof chemical in there.
Yeah, so takeaway coffee cups. I always say this with any to-go container. If you had just a regular like cardstock piece of paper and you poured coffee into it, would your hand get wet? And the answer is yes, your hand would get wet. So there's something, that shiny something on the inside of it is keeping coffee on the inside of it.
Is that PFAS? Is that what that is?
It's a mix of PFAS and other chemicals. I know people are always concerned about their direct exposure right then as they're drinking their coffee, but I like to more so think, okay, so you're going to throw away that coffee cup that's going to go into a landfill, that's going to spend how many years leaching and degrading into our soils, which is going to end up on the farms where we're getting our carrots from.
So don't worry about the damage you're doing to your own body. Worry about the damage you're doing to the environment.
Your grandkids.
That's so harsh. Maybe everyone needs to go out and get, a reusable takeaway cup.
Yeah.
But then I'm like, do they have chemicals in them? Oh my God. Everything has chemicals.
Yeah, you can't think about it too hard.
So if you don't have a reusable coffee cup, what the hell are you doing? Go get one. And if you do have a reusable coffee cup, good on you. You're saving the environment and your grandchildren, apparently. But if you do have one and you forget to bring it in one day, that's okay. Don't beat yourself up. Get a takeaway coffee cup and just do better next time. Charlie B wants to know if microwaving food in plastic is bad.
In plastic? Yes, don't do that. If you're sticking something in the microwave and it's coming out softer than it went in, don't. Like, that's not a toxicologist speaking. That's a person.
That's just general knowledge.
Yeah, that just doesn't feel right. Don't do it.
Yeah, no. Move it out of the plastic container, put it into a bowl or on a plate,
Yep.
and then heat it up. That's some good advice right there. And if you want to send in your listener questions for our experts to answer, follow Travelling Science on Instagram to see who our upcoming guests are. Send me any question and I will ask the guest on your behalf. For example, next week I'll be talking to a reproductive biologist all about menstruation cycles and pregnancy. So no matter your gender, you must have questions. Don't act like you're not curious. Who inspires you most? Can be anybody, living or dead.
I think anyone who does something that is that's against the norm. Anyone who does something because they want to do it and that's the only reason they do it, they inspire me. And every day I try to be more like them. Yeah, I always think about like the women who came before me in STEM. I mean, even me, sometimes like I'm one of the few people from my family who's ever left Tennessee, and that was hard. But I was very encouraged to get an education. So thinking about the people who have not been encouraged to do something that they know they need to do, I can't imagine how hard it is.
Awesome. That's really inspiring. Very cool. If you could do something completely different with your life that wasn't science related, what do you think you would do?
I love reading books, and I would love to be a novelist. I think I would love to be able to do that.
Novelist. Nice. Do you enjoy writing? Are you a good writer?
I used to senior year of high school, I was an exchange student in Spain, and every single day I like just wrote meticulously what I did every single day for that entire year. And I loved writing. And so I've always kind of journaled, whether it's been every day like that or every now and then, which is what I do now. But I don't know, just the creative freedom of being a novelist. Like I'm not really that creative, but I aspire to be. And so, yeah, something I would love to do.
That's awesome. Well, I think writing is definitely something you can do in your spare time, although I realize you probably don't have any spare time, but you will get that back eventually.
Yeah, and there's a lot of writing I have to do that I don't like doing.
What do you love most about science?
So I love asking the question and the thought process and the thought experiments of how am I going to answer that? And so like it's just this really beautiful process of finding a question that you're really passionate about or you really have to know the answer to, and knowing that you're the only person who's going to put the time into figuring out that answer. And so you get to work really hard and like see what people have done before you and then answer the question. And then there's a split second. I say this all the time. It's annoying, but I think every scientist loves the few seconds that you're the only person in the world that knows the answer to the question. And then you're the person who gets to tell them. Like, it's just the most rewarding, exciting thing. I love it.
Interestingly, this is the same answer that Professor Peter Doherty gave last week. Must be a pretty good feeling to discover something for the first time in history. But what about the worst thing? What's the worst part of being a scientist, a science student?
I'm going to answer as a grad student. The worst part about being a grad student is I think that it can be very isolating. Like I said earlier that I have an amazing group, a support group of fellow grad students, but all of our paths are so individual. We're all working on our own thing. We're all having our own struggles, whether it be with peer relationships or mentor-mentee relationships. And so sometimes, I don't know, sometimes when you're in a crowd and you feel like you shouldn't be alone, like that can be the most lonely, isolating time because you feel like you are the most alone then. And so that has been a struggle that I know I've dealt with the past 3 years, and I know all my friends also have. So that's the hardest part. And I don't think that's unique to grad students. I think that's probably part of just being in your 20s. And so I don't want to act like we're the only population that feels this.
I think that's part of being human in general.
Yeah.
Is, they say the world is more interconnected now than ever, and you can talk to anyone anywhere in the world, and at the same time it's like, why do I feel so alone?
Yeah, it's hard. Part of the human experience.
I just wanted to chime in here and say that feeling alone is totally normal and common for everybody, myself included. Just remember that we're not alone, and there's always someone you can talk to or someone you can call whenever you're feeling sad. Being a toxicologist, do you have a favorite toxin, not including the one you're studying?
Oh, organophosphates. I think they're the spiciest of all of them. So there's this thing called organophosphate-induced delayed neuropathy. So it's a mouthful, but the idea of it is someone can be exposed to it, but not experience the symptoms of the delayed neuropathy. So that means that the neurons are dying, but there's a delayed death. And so you can be exposed to it and go on with your life and then have this delayed neuropathy that is specifically caused by organophosphates, which is very unique. And then, so they're used in agriculture, but I think politicians love organophosphates. Politicians are poisoning each other with organophosphates all the time.
That does sound spicy. This delay, is it a couple of hours or like months, years?
I would need to check in on it. I think it depends on the type of exposure you had. Was it a chronic exposure? Was it an acute exposure? But all I know, or all I can remember right off my head, is that it is delayed. But then politicians, like I think Kim Jong-un's brother was poisoned with organophosphates, and then a president of Ukraine's in 2004 was poisoned with it, like a really acute exposure, and they end up with like these blistery, like skin lesions.
This stuff sounds crazy. Apparently during the election campaign in 2004, Viktor Yushchenko was poisoned with dioxin in an assassination attempt, but he survived, made a full recovery, and ended up winning that election. However, Kim Jong-un's brother was not so lucky, and in 2017, he was exposed to a VX nerve agent in Malaysia and died shortly afterward.
Organophosphates, they're the spiciest.
Freaky. Avoid organophosphates at all cost. Do you have a favorite part of the brain? Is it the cerebellum, or is there something else that you love?
So I do love the cerebellum. I think it's objectively the most beautiful part of the brain. If you look at a sagittal section, so a section from the side of the brain, it's the most beautiful part of the brain. And I kind of I feel like it's the underdog of all the other brain regions. It's been traditionally known to be involved in motor movements. And so that's really what a lot of people think that's its only role and responsibility. But I don't know, in the past decade, we're learning, and we're continuing to learn, that it's actually involved in all of these other processes that make us human. And so I feel like it's kind of the just underrepresented, underexplored region, and that makes it mysterious, and I like mystery.
There's so much we don't know about the brain that we're still figuring out. And you're contributing to that work, and it's incredible. So Elizabeth Plunk, thank you so much for coming on Traveling Science today and telling us all about your work. I truly appreciate it. I've just got one more question for you to finish us out. Considering everything that we've talked about here today, do you have a top piece of advice, something you'd like to share with all the listeners that could help them to live a smarter, happier, or healthier life?
So I'm sure you can get bogged down and really anxious hearing about all these chemicals, especially when they're exposures that you can't really control. And so my advice is to just not worry about that. If you can't control it, there's no need to worry about it. Get outside, play outside, have fun. It's that alone we know is good for the brain. And I think protecting your mental health and just taking care of yourself physically and mentally is so important. So my advice is go play outside.
So there you have it, legends. That was graduate student Elizabeth Plunk sharing her wisdom on neurodevelopmental toxicology. And I just loved her attitude about it all. Yes, PFAS chemicals are everywhere. Yes, they could be harmful to our health. But the takeaway message is, don't stress about it. We're doing the research that needs to be done. And in the meantime, enjoy life. Go and get a takeaway coffee. Go and try downhill skiing. Get outside and play in nature. Just make sure to avoid those politicians with their spicy organophosphates. Anyway, legends, thanks so much for listening in today. If you haven't already, subscribe to Traveling Science, and if you can, leave a review. I would really appreciate that. Also, follow Traveling Science on Instagram and send in your listener questions for next week's interview with our reproductive biologist. Finally, if you stick around to the end, I always leave you with a little secret. And this week's secret is that when people ask me what my diet is, I don't really know what to say. I'm kind of vegetarian. I'm trying to be more vegan, but also if my aunt cooks me a tasty roast for dinner, you better believe I'm gonna eat it. So recently, I've just started telling people that my diet is a Jessitarian. I eat what Jessie eats. So there you have it, legends. Thank you so much for listening to Traveling Science, the show that's sharing science with the world, and I'll catch you all next Science Sunday. Cheers.